Hello everyone. In this lecture I will focus on implementation of Boolean expression or Boolean function using PLA. In last lecture I focused on PAL. Here I will focus on PLA, which is nothing but Programmable Logic Array. And since it is PLA, so it is Programmable Logic. That means we will have Programmable AND followed by Programmable OR. So let's solve an example where we will use PLA to implement some Boolean function or Boolean expression. So suppose this is the question that implement the following Boolean expression using PLA, which is Programmable Logic Array. So functions are here. We have three functions f1, f2, f3, where f1 is given by this summation m, f2 is given in terms of abcd, f3 is also given in terms of summation m, but here I have don't care condition also. Okay, now in previous example, like in previous lecture when I taught PAL, there I have already used this to implement using PAL and I solved this too. Okay, so in this particular example I will simplify this f3 only because f1 and f2 is already simplified in previous lecture, and the simplified version of f1 and f2 is actually this thing. f1 after solving using kmf will be a d bar plus b d bar plus c d bar plus a bar c bar d bar, and f2 after solving using kmf will be, or solving directly, will be b bar c bar plus a bar b c d bar. Now let me see what will be the simplified version of f3. So f3 is given like this. So here I make the kmap with 16 elements or 16 cells because we have 4 input variables. So 4 input variables means we have 2 raised to power 4 cells in the kmap. Now for this 0, 2, 8, 10 and 14 I write 1, 0, 2, 8, 10 and 14 I write 1, and don't care will be at 4, 5, 6, 12, 15. So 4, 5, 6, 12, 15. Now if you see here, so this 4, because this are 1, 1, 1 and here 1, 1 is here, this cross. So this cross and this cross I will consider as 1, and this cross I will consider as 0. So considering these 3 cross as 1, I will get a pair of 8 element. Okay, this 4 and this 4 will give a pair of 8. So that will result in d bar only. That means function f3 is nothing but d bar. Okay, so now I am going to implement this, and since we have 4 input variables, so we will need 4 input buffer a, b, c, d, and output from these input buffers will be a bar, b bar, c bar, d bar. Okay, now what I will do, so here if you see, this is the function. Here I have written functions f1, f2, f3. So if you see here, number of AND terms are AD bar, BD bar, CD bar, A bar, C bar, D bar, B bar, C bar, A bar, B, CD bar, D bar. And remember one thing, PAL, PLA or PROM, they have some fixed structure. So even if I need D bar, this will be coming from some AND gate, not directly. Okay, so that means here I need 7 AND gates, right? One for this, one for this, one for this, one for this, 4, this is 5, this is 6, and this will come from 7th AND gate. Remember one thing, this will come from AND gate, not directly. So I use 7 AND gates, 1, 2, 3, 4, 5, 6, 7, and this is programmable AND plus programmable OR. So AND OR both are programmable. So any number of input can be used, and we will have cross to denote the connection because dot is used to represent fixed connection, right? So if you see here, number of outputs are 3, f1, f2, f3. Hence we will need 3 OR gate to implement these outputs. So I am having 3 OR gates. F1, this will give f2, this will give f3. Now if you see, f1 is nothing but ad bar plus bd bar plus cd bar plus a bar, c bar, d bar, and see none of the terms are repeating here, right? So f1 is this thing. So from this 4 I may get that thing. Okay, so see, f1 is ad bar, so here I need some ad bar, then I need some bd bar, then cd bar, a bar, c bar, d bar. These are the required output from AND gates, right? So b bar, c bar, here it is a bar, b, c, d bar. From here I need d bar. Now how to get these things? So see, here ad bar is there, so a and d bar will be connected to this ad bar, bd bar, b and d bar will be connected, cd bar, c and d bar will be connected, a bar, c bar, d bar. So a bar and c bar actually, right? C bar and d bar. Here b bar, c bar is there, so this is b bar, it is c bar, this is a bar, b, c, d bar. So a bar, b, c and d bar are connected here. From here I will have only d bar as input, right? Now f1 is nothing but this thing, ad bar plus bd bar plus cd bar, like these four terms, right? So what I want from f1, I need this and this, right? So I will get f1, required f1, right? This thing. For f2 it is b bar, c bar plus a bar, b, c, d bar, right? So if you see, this is b bar, c bar, a bar, b, c, d bar. So from here I will get f2. f3 is nothing but this d bar, and from this I am getting d bar, right? So f3 will be d bar. Now remember one thing here, since all the AND terms are different, hence we are taking this only cross. Okay, but suppose if I got this f3 anyhow, if I got this f3 as, not here, I am changing the example, suppose I got f3 as d bar plus b bar, c bar. In that case what we have to do, you have to use f3 as d bar plus b bar, c bar, right? So here is b bar, c bar, I can use b bar, c bar from here and d bar from here to get f3 as d bar plus b bar, c bar. So don't think we put cross once only, cross can be multiple number of times. Okay, so this is all about Boolean expression implementation using PLA. If you have any doubt, feel free to ask me. Thank you.